Every day, millions of people around the world consume whey protein as part of their diet. It is produced from cow's milk and goes through various processes in factories to become a high-quality protein powder. But how are over 10,000 bottles of whey protein produced every day? From dairy farms to the production plant, we will uncover the secrets behind the manufacturing of one of the most sought-after supplements in the industry. Whey protein comes from cow's milk. Whey, the liquid part that is separated from the curd during cheese making, has been a byproduct of cheese production for thousands of years. Many years ago, whey was considered an unwanted byproduct of cheese and other dairy products. This liquid was obtained as a result of the process of coagulating milk to make cheese and other dairy products. Whey was a highly polluting byproduct for the environment. Discharging it could have negative effects on water and soil quality. Over time, as technology and understanding of nutrition advanced, the nutritional value of whey proteins and other whey components was recognized. This led to the development of more efficient and sustainable methods for processing whey into useful products such as proteins. The process begins on dairy farms, where cows are raised and maintained specifically for milk production. On the farm, it is believed that happy, healthy cows produce high-quality milk, and quality milk is the first step in a high-quality protein supplement. An average dairy cow can produce around 30 liters of milk per day. Cow's milk is made up of 3% protein. Of that protein, 19% is whey protein. Cows are milked twice a day, usually by automated milking machines. During milking, milk is expressed from the cow's udders. Milk is rich in nutrients, including proteins, fats, carbohydrates, and minerals. Freshly milked milk is temporarily stored in refrigerated storage tanks to keep it fresh and prevent contamination. These tanks are designed to maintain the milk at cold temperatures to prevent bacterial growth and ensure its quality. The milk is transported from the dairy farms to the cheese processing factory. Each day, the fresh milk is transported directly to one of the local cheese factories. Here it is separated into curds and whey. Refrigerated transport is usually used to keep the milk at the correct temperature during the journey. At the factory, the milk is unloaded from the transport trucks at specific receiving areas. A quality check process is carried out on the milk to ensure that it meets the required standards. Before continuing with the manufacturing process, the milk that has just arrived at the factory is stored in refrigerated storage tanks until it is ready for processing. Prior to pasteurization, it is important to check the quality and freshness of the milk to ensure that it meets food safety standards. Milk is pumped from storage tanks through a system of pipes to a heater. In the heater, the milk is typically heated to around 60 degrees Celsius for approximately 30 minutes. This heating process is intended to kill and deactivate any harmful bacteria present in the milk, thereby increasing its safety for consumption. After the heating phase, the pasteurized milk undergoes rapid cooling to reduce its temperature to 4 degrees Celsius. Rapid cooling stops the heating process and prevents further cooking of the milk, which could negatively affect its quality and taste. Throughout the pasteurization process, the temperature of the milk is carefully monitored and controlled to ensure that it remains within specified ranges. After pasteurization, the milk is transported to a specific processing unit designed for the separation of its components. The pasteurized milk is placed in a large container and undergoes a mechanical separation process. After the pasteurization process, a coagulant is added to the milk, resulting in the formation of a solid mass known as curd. During this process, the remaining liquid, known as whey, contains concentrated proteins and other soluble components that are separated from the curd. In this cheese factory, the curd is used to make fresh cheeses, while the remaining whey is used for a second line of business. During the separation process, a physical method such as filtration is used to separate the curd from the whey. The resulting liquid fraction is whey, which is rich in whey proteins. This stage of the process is essential to obtain the desired protein component, which is the basis of whey protein. The liquid whey fraction may still contain small amounts of unwanted fat and minerals. In some cases, an additional purification step is performed to remove these components and obtain a cleaner, more protein-concentrated whey fraction. In some processing facilities, microfiltration and cross-filtration are used to further refine the whey protein fraction. These methods allow the removal of impurities and the concentration of whey proteins, resulting in a purer final whey protein product. This natural, low-temperature process separates the protein from the fats and lactose, resulting in a finished product that is extremely rich in protein while retaining important nutrients. The result of this step is a liquid whey fraction that is highly concentrated in protein with minimal fat, carbohydrates, and other unwanted components. Once filtered, the whey undergoes the evaporation process. The whey is introduced into industrial evaporators designed to remove excess water from the liquid fraction. The evaporation process is carried out at a controlled temperature to avoid damaging the proteins present in the whey. The temperature can vary, but is usually kept relatively low to preserve the quality of the proteins. Evaporation is a controlled process that gradually removes water from the liquid whey fraction. During this process, the water evaporates and turns into steam, while the proteins and other solids remain in concentrated form. Once much of the water has been removed, the concentrated liquid fraction undergoes a drying process. Drying involves introducing hot and cold air into the concentrated liquid stream. The hot air helps to further evaporate the water, while the cold air helps to cool the product. This drying process ensures that the final product is a powder with minimal residual moisture. The resulting powder is then sieved to remove any larger particles and ensure size uniformity. Once this stage is complete, the whey powder is fed into a blender to remove any remaining moisture and achieve a homogeneous mixture. It is then packaged into bags for sale to wholesalers. The bags are sent to the protein factory. It is the largest protein factory in the world. A factory that operates like clockwork 24 hours a day, 7 days a week, handling several hundred tons of whey protein and producing thousands of products. Thousands of bags of whey protein powder arrive at the dietary supplement company's extensive warehouse every day. The materials will then be taken from here to the weighing room, where all the raw materials will be weighed. All raw materials pass through a fine sieve, usually with an opening of 2 millimeters. This ensures that all ingredients are gently broken down and easy to mix. The whey protein powder is then transported to the mixing area, where different flavors are added to give each product its unique and delicious taste. The protein powder is then mixed for a few minutes in these rotating drums. An operator places the empty canisters on the conveyor belt to start the filling process. At this stage, an automatic filling machine is used to fill the containers with the correct amount of protein powder. In this process, an employee uses a vacuum hose to transfer the protein from the bags to the packaging machine. The filling is carried out with precision to ensure that each container has the specific amount of protein. After filling, each container undergoes a weighing process to verify that it contains the correct amount of whey protein powder. The canisters continue along the conveyor belt until they reach the next stage, where another operator places a measuring spoon in each canister and closes the corresponding lid properly. A visual quality control is performed to ensure that the product looks good and that there are no visible contaminants. Each container is labeled with important information such as the product name, nutritional information, usage instructions, expiration date, and batch number. Once the labeling process is complete, an employee inserts a plastic ring into the lid of each jar. The jars are then sent to a heat sealing machine that seals the plastic rings with heat, ensuring a precise and airtight seal. The filled and verified containers are placed in boxes for easy transport and distribution.